Friends, so far we have studied the analysis of the continuous beams with both the ends fixed by using the moment distribution method. Now we will discuss about how to analyze the continuous beam with one end is on simple support and another end is on fixed support. Here this is the problem. Analyze the beam shown in figure by using the moment distribution method and draw bending moment diagram, shear force diagram and elastic curve. Here A to B, the moment of inertia is 1.5 I and is subjected to 2 point loads of 40 kilonewton each at 2 meter distances from A and B respectively. Then in span BC, it is subjected to a point load of 50 kilonewton at a distance of 2 meter from B and 4 meter from C, and is subjected to, in addition to this, it is subjected to 20 kilonewton per meter of UDL over the entire length. The total length is 2 plus 4, that is 6, and moment of inertia is 2I. In span CD, it is subjected to a point load at the center, that is 2 meter from either end, and moment of inertia is I. Here there is a variation of the moment of inertia. First we have to calculate the fixed end moments by considering all the ends as fixed. That is the first step. Here start from AB, that is MFAB. Here we have to consider A as the fixed end. Then the fixed end moment at A, due to there are 2 point loads 40 each. Then MFAB, that is anti-clockwise, that one is W minus WAB square by L square. First consider first point load, that is 40 kilonewton. For that A is 2 meter, B is 4 meter, L is 6 meter, that is minus 40 into 2 into 4 square divided by 6 square. For the second point load, that is A equals, that is A is 4 meter, B is 2 meter, then you can calculate, that is WAB square by L square, that one is minus 53.33. Similarly, MFBA, from the other end, if you calculate, the formula is WA square B by L square. Here you will get, by substituting the values of the 2 point loads, one is 40 and another one is also 40. Then 40 into 2 square by 4, 40 into 2 square into 4 by 6 square, plus 40 into 2 into 4 square divided by 6 square, that equals 53.33 kilonewton meter. Now from end A is anti-clockwise, from end B is clockwise. Now go to the next span BC. Here it is subjected to a point load and a UDL. You have to calculate the fixed end moments due to the two loads separately, and then by principle of superposition add them. For UDL, that is WL square by 12, that is anti-clockwise. For point load, that is WAB square by L square. Then by substituting the values of loads and distances, we will get, that is 20 into 6 square divided by 12, that is negative, minus 50 into 2 into 4 square divided by 6 square, that one is minus 104.44. Then MFCB, that one is clockwise, that one is WL square by 12 plus WA square B by L square. Then that equals 20 into 6 square divided by 12 plus 50 into 2 square by 4, 2 square into 4 divided by 6 square, that one equals 82.22 kilonewton. Then come to the next span, that is last end span, MFCD, that is anti-clockwise, it is subjected to point load at the center, hence that is formula is minus WL by 8 minus 80 into 4 by 8, that one is minus 40 kilonewton meter. Similarly, MFDC is, that is clockwise, WL by 8, that one is 40 kilonewton meter. Then the second step is you have to calculate the distribution factors at the joints only. Here at joint B, two members are connected, one is BA, one is BC. Similarly, at joint C, two members are connected, CB and CD. Then for joint B and C, we have to calculate the distribution factor. Here, joint B, two members are connected, one is BA, one is BC. Similarly, at joint C, two members are connected, one is CB, one is CD. Here, K, that is relative stiffness value. K is given by I by L. K equals I by L. With respect to B, A is non-continuous and is on simple support. Hence, K equals 3/4 of I by L. 3/4 into moment of inertia is 1.5 times I. L is 6 meter. Then that one is 3I by 16. K for BA is 3I by 16. For BC, with respect to B, C is either continuous or fixed. Here this one is continuous. Hence that is 2I by 6. Moment of inertia is 2I and length is 6. Therefore, that equals I by 3. Then next joint CB. At joint C, two members are connected, one is CB and one is CD. With respect to C, if you observe this, B is continuous. Here there is a continuity. Therefore, K equals I by L. Here the moment of inertia is 2I, length is 6. Therefore, that is 2I by 6. That one is I by 3. For CD, with respect to C, D is fixed. Therefore, that is I by L. I is moment of inertia is I, length is 4 meter, hence that is I by 4. Here summation of K at joint B, that one is, here if you simplify this one is 0.52 I. Similarly, this one is 7I by 12. Here then summation of K at joint B and C. After that we have to calculate the distribution factor at that joint. Here, this distribution factor, it is distributed among these two members. That is, one is for BA, K divided by KBA divided by KBA plus KBC, that one is 0.36. Similarly, KBC divided by KBA plus KBC, that one is 0.64. Then CB, here summation K is 7I by 12. K for CB divided by summation K, that one is 4 by 7. Similarly, K for CD divided by summation K, that one equals 3 by 7. After knowing the values of the distribution factor, we have to go for the moment distribution table. The moment distribution table, here this one is the moment distribution table. Here start from joint A, then here this one is joint, then member, distribution factor, fixed end moment. Here at joint A, AB is the only member. At joint B, two members are connected, one is BA and another one is BC. At C, two members are connected, one is CB and another one is CD. Another one is CD. At D, two members are connected, one is CB, one is CD. At D, only one member, that is D to C. Here, no distribution factor for the end member, that is AB and DC. For interior support, for the joints, we have just now we have calculated for BA, that is 0.36, for BC that is 0.64, and for CB that is 4 by 7, for CD that is 3 by 7. No distribution factor for AB and DC. Then we have just now we have calculated the fixed end moment. MFAB is minus 53.33. MFBA is 53.33, that is clockwise positive. MFBC, that is anti-clockwise, minus 104.44. MFCB is 82.22. Then MFCD is minus 40, that is anti-clockwise. MFDC is plus 40. Here the end support at A, that one is on roller or hinge or simple support. Final moment at the end support, if it is on roller, hinge, simple, then that is 0. You have to balance that. That process is known as releasing the moment. We have considered this one as fixed support, A as fixed support. Then we have calculated the fixed end moments. Here we want to release that moment by adding the moment of same magnitude with opposite sign. Here the fixed end moment we have calculated by considering it as fixed support. Now we have to add plus 53.33 to make it 0. Here 50% of this added moment, to make it 0 or to balance it, here we have added the releasing moment. Half of that one is carried over to the next joint from A to B, that is 50% of 53.33 is 26.665. Then again we have to add all these things. This is initial moment, minus 53 plus 53.33, that is 0. Here 53.33 plus 26.665. Here we have to carry over the half of or 50% of the moment from A to B with same sign. If it is positive, then carry the moment with positive sign. If it is negative, then carry the moment with negative sign. Here the summation of these two is 80. Here there is no releases. If D is also on simple support or hinged support, then you have to release that. Here D is fixed, no need of releasing the moment. Then here by observing this, A is 0, since that is the end support, that is on simple support, hence that is 0. At B there is an unbalanced moment. Here by observing these two values, one is plus 80, one is minus 104.44. Here the difference is 80 minus 104.44, that one is minus 24.44. That is unbalanced moment. This unbalanced moment we have to balance it by adding plus 24.44 plus 24.44 to make it 0. You know that at joint, when the equilibrium condition is reached, the joint is, the summation of the moments at that joint is 0. Here now it is unbalanced. We have to make it balance, that is balancing. That one is 24.44. 80 minus 104.44, that is minus 24.44. We have to add plus 24.44 to make it balance, that is plus 24.44 into 0.36, that is 8.8. That is for BA. 24.44 into 0.64, that one is 15.64 for BC. Similarly here also, here by observing these two values, this one is 82.22, this one is minus 40 at joint C. Now by observing this is unbalanced. Unbalanced means we have to add 82.22 minus 40, that is 42.22. Then we have to add minus 42.22. We have to add minus 42.22. We have to distribute among the two members, that is CB and CD. Minus 42.22 into 4 by 7, that is minus 24.06. Minus 42.22 into 3 by 7, that is minus 18.15. Here this process is known as balancing. Here by observing these four values, the summation of these four values must be equal to 0. The summation of these four numerical values at joint C must be equal to 0. Now carried over, if the end is fixed, from the preceding support carry the moment. If it is carry, 50% of the moment is carried. If the support is the end support with simple roller or hinge, no need of carry over. Here, by observing this, B to A, here B is, this one is B, BA, B to A, there is no carryover since this one is end support which is on simple support. Then from B to C, B to C, there is a 50% of the moment is carried from B to C. B to C. Here I have shown the arrow mark, that is half of that with same sign. Here this is 15.64, half of that, that is 7.82 with positive sign. Here similarly C to B. C to B there is a continuity. B to C there is a continuity. Hence we have carried over. Here C to B there is a continuity. Hence we have to carry the moment. You have to carry the moment, half of this, that is minus 12.03. Minus 12.03, half of 24.06. Then C to D, here this end is fixed. This end is fixed. Hence 50% of the moment is carried from C to D. That is C to D, there is 50% of the moment is carried. That is half of minus 18.15. That one is minus 9.075. Here in the second cycle, again we have to balance. Here by observing this at joint B, there is an unbalanced moment of minus 12.03. That we have to balance it by adding plus 12.03. That is distributed among these two members. That is plus 12.03 into 0.36. Here you will get 4.33. Plus 12.03 into 0.64. That you will get 7.69. Here the summation of all these equals 0. 7 plus 4 minus 12, that is 0. Then here there is an unbalanced moment of 7.82. That 7.82 can be balanced by adding minus 7.82, and that minus 7.82 is distributed among these two members. Minus 7.82 into 4 by 7, that is minus 4.45. Minus 7.82 into 3 by 7, that is minus 3.36. Here the sum of these three must be equal to 0. Again there is a carryover. There is a carryover. B to A, there is no continuity. That is discontinuous, or there is the end support on simple or roller. Then there is no carryover. There is no carryover. Then from C to B, C to B there is a carryover, B to C there is a carryover. From C to B there is a continuity, B to C there is a continuity. Therefore, half of minus 4.45, that one is minus 2.22 with same sign, 50% of this. Similarly, 50% of 7.69, that is 3.84, is carried from B to C. Then C to D, half of minus 3.36, that is minus 1.68. Again, in the second cycle, this one is the first cycle, this one is the second cycle. In the third cycle, we have to, in the third cycle, again we have to balance this. Here there is an unbalanced moment of minus 2.22. We have to balance it. That is, here we have to distribute the, by adding plus 2.22 to plus 2.22 into 0.36, that is plus 0.80, and plus 2.22 into 0.64, that is 1.42. Then here next joint 3.84 is to be balanced by adding minus 3.84, and minus 3.84 is distributed among these two members. Minus 3.84 into 4 by 7, that is minus 2.19, and minus 3.84 into 3 by 7, that is minus 1.65. Again in the next cycle, that is 1, 2, 3, in the fourth cycle, we have to carry the 50% of the moments. Here there is no carryover since this end is discontinuous or non-continuous. B to C, there is carryover, that is half of 1.42, that is 0.71, half of 2.19, that is minus 1.09, with same sign it is carried. Then minus 1.05, 0.65, that is half of that, minus 0.82, that is carried over towards D. Then again there is an unbalanced moment. Unbalanced moment, that is minus 1.09. Here we have to balance it by adding 1.09, that is plus 1.09 into 0.36. This one is 0.39 and this one is 0.770. Again, at joint C, there is an unbalanced moment, that is plus 0.71. We have to balance it by adding minus 0.71. Minus 0.71 into 4 by 7, that is minus 0.40. Minus 0.71 into 3 by 7, that is minus 0.31. Again, carry over. 50% of this moment is transferred to joint A. But here this end is end A. Already we have made it 0. No need to carry over. Then here from B to C, half of 0.7, that is 0.35. Here from C to B, half of minus 0.4, that is minus 0.2. Then from C to D, half of minus 0.31, that is minus 0.15. Again you have to balance this in the next cycle, that is 1, 2, 3, 4, 5, fifth cycle. Then you have to balance this. You have to distribute point plus 0.2 among the two members, that is 0.2 into 0.36, that is 0.072, and 0.2 into 0.64, that one is 0.0128. Then here 0.35 is divided into, that is by balance, to balance this we have to add minus 0.35. Minus 0.35 into 4 by 7, that is minus 0.199. Minus 0.35 into 3 by 7, that is minus 0.15. Then 50% of this moment is carried over. 50% of this moment is from C to B, it is carried over. From B to C, 50% of this one is carried over. Again, balance this. Finally, here the fraction is very small, that is the value of the moment is very nearly 0.01. In that condition we have to close the cycle. Then I have to add here 53, one is negative, one is positive, the summation is 0. Here 53.33 plus 26.665. Here you have to add all these things to get 94.416. This one is positive, that means that is clockwise. MBA is 94.416. Then MBC, that one is minus 94.438. Here there is a small difference, that is negligible. Then at joint C, two members, one is CV, one is CD. MCV is 63.643. MCD is minus 63.622. There is a small difference, neglected. Then at MDC, this one is, by adding all these things you will get 28.205. that is the final moment at that point. Here now we want to draw the bending moment diagram. Here this one is your given beam that is subjected to the point loads. Here this one is A, this one is B, this one is C, this one is D. Here you have to show the arrow marks for this one. That is, here the moment is 0. Here the moment is 94.416. This one is here, this one is clockwise, this one is anti-clockwise. Similarly, MCB, that is clockwise, MCD is anti-clockwise. Then MDC is clockwise. Here, by observing these support moments, here this is 0 and this one is 94.416. Here first draw the reference line or datum line. Then here this one is hogging moment. With respect to this datum line, we can show the hogging moment above the reference line. Then this one is 94.416. This one is 0. Here by joining this, you will get the support moment in AB. Similarly, the support moment in BC, here this one is 94.416 and then this one is 63.64 kilonewton meter. Here by observing this one is hogging. Then here we have already shown hugging moment above the reference line. This one is 63.64. Draw the ordinate and then join the two ordinates by a straight line. Here this is the support moment diagram in span BC. Then for CD, here this one is already drawn 63.64. Here this one is again by observing this one is hugging moment of 28.20. Here draw an ordinate that is hugging, hence show it above the reference line and then join this. Here this is the support moment diagram. Now we want to draw the simply supported beam bending moment diagram. Here this one is subjected to 2-point loads, that is 40 kilonewton each. The support reactions both RA and RB are equal, that is 40 for each. 40 into 2, this is 80. 80 remains constant. Then at support it is 0. Then this is the bending moment diagram. It is trapezium, this one is positive, and this support moment that is hugging, that one is negative. Then here you have to calculate the support reaction. By calculation of the support reaction, and then here it will be 93.33. Then 93.33 into 2, that one is 146.67 below the point load. Then at support it is 0. The maximum bending moment occurs at some point somewhere. Here we can calculate, that is bending moment occurs at a distance of x. Write the bending moment equation and differentiate the bending moment with respect to x. Then you will get x equals 2.1665 meter. The maximum bending moment is 146.94, that is at a distance of 2.1665 from here. It is very near to this point load to the right side of that. Then come to this one. Here this one is subjected to point load at the center. Here that one is WL by 4. This one is the maximum ordinate. Then this is the shape of the bending moment diagram, that is span moment, that is simply supported beam bending moment. Here now we want to draw the shear force diagram by considering the moments of all the forces about, by considering only the right part, that is VD into 4. Then this moment 2 to this one, moment 2 to this one, here we will get 31.14. Similarly, summation of MB equals 0, that is LHS. Only you have to consider this is 0, this one is 94.416. Then here we will get VA, that one is 24.264. Then summation of MC equals 0, that is only you have to consider all the forces to the left of this. Then you will get VB. Already have calculated VA. Then in the same way, summation of MB equals 0 by considering RHS. By considering RHS, you will get here VC equals 120.398. Or by applying the equilibrium equations, then to draw the shear force diagram, here VA is 24.264. If you consider the left upward as positive, that is as per our sign convention, left upward, sum of all the forces to the left side. Here sum of all the forces to the left side of this one, that is only the reaction RA or reaction VA, that is 24.264. it remains constant. Here there is a point load of 40 minus 40, that one is 15.736, that one is negative. Again here the shear force remains constant from this load to this load. Here again there is a point load of 40 kilonewton in downward direction. 40 minus 40 minus 15, that is 55.736. This one is negative bending moment, negative shear force. Here VB equals, that is upward, VB equals that we have already calculated, that one is 55.736, that is negative, plus 154, you will get 98.462 as the shear force. Here, from this point to this point, the variation of the bending moment is decreasing since it is subjected to UDL. In this portion, it is subjected to UDL 98.462 minus 20 into 2, that one is 40. Then here for 58.462, here there is a point load of 50, 58.462 minus 50, that one is 8.462. Then from this point to this point, 8.462 minus 20 into 4, this one is subjected to UDL. This one is subjected to UDL, that is minus 71.438. Here, this one 71.438, that is because of the UDL. Then here there is a support reaction VC, that one is 120.398. Then that one is 48.86. It remains constant from C to that point load in between C and D at the center. Then 48.86 minus 80, that one is 31.14. That one is 31.14. Then it remains constant 31.14 minus 31.14 plus 31.14, this that becomes 0. Here this is the elastic curve for this one. Here the moment is that is at the center, that is sagging. At the support it is hugging like this. At the support here the slope is 0.